The policies that are being urged on people, that are short of nuclear Armageddon, don't actually differ in the final result. They will also kill lots of people. Billions of people will starve to death because you cannot support the world with the number of people we have today without fossil fuels.
William Happer is Emeritus Professor of Physics at Princeton University, and he was appointed by George W. Bush to be the Director of the Department of Energy's Office of Science. In 2018, Donald Trump appointed him to the National Security Council. And despite being a physicist, Professor Happer has become interested in climate change and CO2 levels, and his own work has led him to reject the standard scientific consensus on climate change. So, Professor Happer, thank you very much for joining me today.
Thank you, Professor Davis.
Can I ask, before we look at climate change itself, can I ask that, being a physicist by training, as I know you are, how did you become interested in climate change as a subject, which is slightly different from physics?
Well, you mentioned that in the early 90s, I was appointed to head the Office of Science of the U.S. Department of Energy. And I had a big budget. It was $3.5 billion in a time when $1 billion was worth more than today. And so I felt I owed it to the American taxpayers to know what we were funding. So I arranged to have one of our principal investigators, to whom we were paying money, come in once a week and tell me about their research. I thought it would be useful in case I were ever questioned in Congress about, where the taxpayers' money was going. And I enjoyed that very much. I insisted that my assistant directors come and listen to the seminar too and get away from paperwork for a little bit. And the presenters usually were delighted to come too. They were so excited that some Washington bureaucrat was actually interested in the science they were doing. So it mostly worked out very well. The big exception was people working on environmental science. Now I guess I would call it so-called science, but then I had no prejudices. And first of all, they would be very reluctant to even come. I remember one said, well, I work for Senator Gore, and, he doesn't want me talking to you. And I said, well, that's okay. Next time you apply for a grant, you apply to the senator, but don't bother with us because, everybody else who we're supporting, people looking for the top quark or, sequencing the human genome or trying to make progress in plasma physics or materials, they're all delighted to come. All of them, they come to Washington and tell me what they're doing. And so they need a little more money. I can use your funding for them. Yeah. So of course that had the effect you would imagine. They would come snarling to Washington, and give a hostile seminar, and they didn't like to answer questions, I mean, how can you have a seminar without asking questions? That's the whole point of it. So I knew at that time there was something not right about this part of my science portfolio. But, I was a political appointee. So as soon as George Bush lost the election and Clinton came in with Al Gore as his vice president, Al couldn't wait to find me. It's hard to find people in the bureaucracy, but he was eager to fire me. And after about 3 months, he did find me and fire me. I was happy to leave. I wasn't looking for a job in Washington.
Yeah.
But anyway, that's where I got interested. And when I went back to Princeton, they were kind enough to hire me again. I was busy working on completely different things. My group was still in existence, and we were doing some exciting work about medical imaging. And so I was distracted for 4 or 5 years. We did a little startup company that did well. But every evening I would watch the television, and every now and then there would be some ridiculous piece about climate Armageddon, and yeah, I would get very upset because I knew exactly what was going on there and that every word was a lie. And my wife would say, well, if you're so upset, why don't you speak up and tell people? How am I supposed to know? I'm not a scientist. And so I owe my wife, Barbara, the stimulus for beginning to speak up. And she probably regrets it now, but she's been very loyal. So that's the history. Yeah.
Wow. So have you ever did you find the crossover from physics to climate change a straightforward one then in that? Are the connections between the two that you found helpful? Was your physics background useful there?
Well, you know, climate really is nothing more than mostly physics, a little bit of chemistry and geology, but it's 90% physics. So it's not any different from what I had already done. And the reason they invited me to come to Washington was because I'd solved a very important problem in the early days of the strategic defense initiative on the atmosphere, on basically climate. You probably know about that at night, you know, you look at stars and they twinkle. Mm. As a result, when you take a photograph of a star on a plate, or nowadays you'd use a CCD, instead of getting a nice point image, you get hundreds of little speckles. And so you're not sure which one is the real star. And if they're nearby stars, the speckle patterns overlap, and it's very hard to use the data. And the inverse of that is true, you know, for SDI, for Star Wars, we felt obliged to look at every possible defense against incoming missiles, and one of them was high-power lasers. And so a high-power laser aimed at an incoming missile has the same problem as a star trying to illuminate a telescope on Earth, that it has to go through the atmosphere. And so even if the sky is absolutely clear, which it is today in Princeton, a beautiful blue sky, if you try to look at a star, it still has this speckle pattern. And if you try to aim at a missile, your powerful laser beam gets broken up into hundreds of little beamlets, none of them big enough to cause any damage. So it turns out that astronomers have been aware of this really since Newton. You know, it's an old problem. It's a seeing problem. And they knew that you could actually get rid of the distortions if you had a sufficiently bright star. So if you have a really bright star, you can measure the wavefront. The reason it happens is that the plane wave coming in from the star gets wrinkled. So when it goes through when it bounces off the spherical mirror, instead of bouncing a plane wave, you're bouncing a wrinkled wave. It's the wrinkles that make the speckle. Nice. So the trick is that you put the anti-wrinkle pattern on the mirror. It's called a rubber mirror. And then when the wrinkled wave bounces off the wrinkled rubber mirror, you wrinkle it in just the right way that when it bounces back, it's completely flat, or it's spherical, you know, without any distortions. So you know, it's a technical feat. You have to measure the wave. You have to use that information to distort the mirror, but it actually works. But the key is you have to have a bright star with enough light that you can do the measurements fast enough, because the atmosphere is changing rapidly and you have to close hundreds of feedback loops.
Wow.
So anyway, this much was known in 1982.
I was going to say, when I was a student in UCL as an undergraduate, I think they were working on something called a speckle interferometer. I don't know if it's had anything to do with that.
Well, not directly, but of course it's optics. But it is related. I guess you would summarize this as calling it adaptive optics. Okay. Hmm. So astronomers knew how to do adaptive optics if you had a sufficiently bright star. And so if we were attacked from the direction of Sirius, you know, one of the brightest stars in the sky, we'd have no trouble shooting down the missile if he were, you know, obliging enough to come from that direction. But any other direction, we couldn't damage him. So this was presented at a classified seminar in 1982. And I was in the audience and I said, well, I know how to fix this problem. All you need to do is make an artificial star in the direction of the missile. And then you can use the light from the artificial star to correct the mirror and before you launch the high power laser, and then the missile gets hit with the full power, and it's destroyed. So and I said the trick is that at 100 kilometers in the atmosphere, I knew a lot about the atmosphere in 1982, more than most climate scientists. I said at 100 kilometers, this is a layer of sodium atoms, and there's an amazing number. And if you shine a sodium tuned laser there, you produce a bright yellow star, and it makes so much light that you can use that yellow starlight, artificial starlight, to correct the atmosphere in any directions you please. And well, day or night. Well, the audience was a bunch of Air Force generals and colonels, and none of them had ever heard of this, although many were specialists, they had PhDs in physics. And so there was, of course, lots of skepticism, but they said, okay, it's the beginning of summer, work this out, and we'll be back, in August and have a report for us. So I did that. It wasn't very hard to write it up because I already knew most of it. And they came back and they were still very dubious, but to their credit, they took my report and they shopped it around to all of their house experts. It was classified and nobody could find anything wrong with it. And so they let a contract for $1 million to build a sodium laser, and another contract to build a secret observatory, in New Mexico to test it out. And so I was getting a little nervous now, hoping that this was going to work because, it would be a big embarrassment if they'd spent all this money. But it worked the first time. And so that was why I got called to Washington, because I had solved this problem. And it was heavily classified for 10 years. And finally, after the breakup of the Soviet Union in the early 90s, astronomers themselves were beginning to realize you might be able to do this. They didn't realize we had already done it 10 years earlier. And so at that point, thanks to really hard work by a friend, Claire Max, who was at Livermore Labs, the information was declassified. And but if you go to any modern ground-based telescope today at night and look, you'll usually see this yellow sodium beam going up. That's my sodium guide star. So anyway, this is a long-winded answer to your question of
it was very interesting.
About climate, and the answer is I know more about climate than most climate scientists.
I can see that. Let's come on to climate science then, and I just want to take this slowly and test each link as we go, because there are a lot of assumptions, it seems to me, in the way climate science is presented these days. But if you'll forgive me, let's start off very simply and see if we can make some progress on it. But let's start with a very simple question. Is the Earth actually warming? Do we know whether that's a definite yes or a no?
I think it's pretty clearly warming. I mean, some of the best records are the Central England temperature record, and it shows a very small warming, but the warming started 300 years ago at the depths of the Little Ice Age. So it's very likely that most of the warming we're seeing is the natural recovery from the Little Ice Age. There was a really marvelous English climate scientist, or paleoclimate scientist, I guess you might call him, Hubert Lamb. And he was the one who founded the East Anglia, climate research unit, whatever it's called. And he was a good guy, but he wrote a great book that traced the climate history of the world, mostly more in Europe than in the rest of the world, because he was a European. But he pointed out that the climate is never stable. It's almost always warming or cooling. We happen to be in a warming phase now. And in general, warming phases are much better for mankind than cooling phases. Cooling is bad news whenever it happens. Yeah.
So, okay. So the Earth is warming, and it's been up and down over millennia,
Right.
but it is warming. Is CO2, this is the next assumption which I think is made, is CO2 the main cause of the
No,
present?
no, no, of course not. There's plenty of observational evidence that shows that CO2 is not a very important driver. I personally think, again, since I know a lot about the physics of climate, that CO2 is not completely negligible, but it's almost negligible. It's a very small factor in the warming.
And yet, IPCC and other people look at CO2 as being the most important thing to get a hold of and to drive down to zero.
Well, it's, I don't know quite what to call it. It's some combination of groupthink and religious zeal and, embarrassment that you'll have to eat your words. It's many things, but it's certainly not science.
Right. And it's not CO2 that's the primary cause of warming. Well, what does? I mean, you say that, and there's plenty of evidence to show that the Earth has been through periods of cooling and warming and cooling and warming. Many different ice ages have occurred and then come and receded and come back. What does cause that? Do we have any knowledge of what's the real root?
Yeah, I think we have knowledge. I mean, I think that whole field has been set back 30 or 40 years because of the, frenzy over CO2. But one of the first good ideas was the Serbian physicist Milankovitch, who pointed out that as a result of the change of the ellipticity of the Earth's orbit over 100,000 years and the change in the tilt of the axis over 40,000 years and the, 25,000 year precession of the equinoxes, that the sun power on the north, the Arctic in particular, varies a huge amount, and these seem to be correlated pretty well with ice ages. So when the Earth, they typically take, say, 65 degrees latitude north. From 65 north, if that gets a lot of sunlight, that melts any ice sheets, and we get into an interglacial like we're in now. But that doesn't last long. So sooner or later, it gets colder in the north, even in the summer. And then the ice sheet starts to grow. There's not enough sunlight in the summer to melt them away. So every year they get a little bit bigger. And that's when the ice sheets start to advance south. So that's something that's a time scale of 100,000 years, tens of thousands of years, different time scale than what we're talking about now. Now we're talking about a few hundred years.
Or even tens of years, people are talking about in terms of.
That's right. That's right.
Crazy on
well,
the.
Climate changes on all scales, and it always have. For example, it's interesting if you read, the Bible. These Old Testament stories about famine in the land of Canaan, and so. Jacob had to send his sons to Egypt, to get enough to eat, because Egypt had the Nile, which continued to flood, and so they had food, but you couldn't grow a crop in Palestine. So this is nothing new, and there's plenty of proxy evidence. You don't have to look at the Bible to realize that this has been happening. And that's a very interesting question that is hotly disputed today. One group believes that it has something to do with the sun, and I would guess I'm kind of neutral on this, but I believe that they're more likely right than any other group. So it probably has something to do with the sun. But we don't understand the sun as well as we should. We don't have precise measurements of the sun for very long. For example, I mentioned we've got several hundred years of temperature in the central England, but we don't have anything like that sort of precision record for the sun, for the solar output and things like that. So you can make up almost any theory and you can't falsify it because the data isn't there. So the one thing that I'm really pleased about, and one thing I supported when I was a bureaucrat, was good instrumentation to make systematic measurements of important climate parameters over many years. That's very hard to do, if you go to Congress and say, I want to continue this measurement network. Well, didn't you measure it last year? Isn't that good enough? No, it's not good enough. You have to keep measuring it year after year after year for the data to really be useful. And so that has been happening to some extent, not as much as it should have, because we've wasted so much time, so much money on computer modeling, which is, in my view, just a complete waste of money. But the money we've spent on satellites and ground-based sensors, I think, has been well worth it. I wish we'd spent more.
I take your point about these periodic changes of the sun. At least we know there's an 11-year cycle for sunspots, but there may well be other longer cycles going on which we're unaware of.
That's right. We really don't know yet. And
but all the
let me just follow up on that. There is a very good group that works on this. The names to come to mind are Henrik Svensmark in Denmark and Nir Shaviv in Israel. And they have a fascinating theory that it's indirect effects from the sun that affect the climate. So it's pretty clear that sunspots seem to have something to do with the climate. In the middle of the Little Ice Age, for example, there were almost no sunspots. It was called the Maunder minimum, after astronomer Maunder, who pointed that out for the first time. And so people have wondered, somehow it looks like when the sun has a lot of sunspots, it's warmer, and when it has no sunspots, it's colder. And so the Svensmark theory is that that's because the sunspots indirectly affect climate by modulating cosmic rays. Sunspots are where huge loops of magnetic field come out of the sun, and they are enormous. They extend all the way to the Earth orbit. And one thing a magnetic field does is it deflects cosmic rays. So when there are lots of sunspots, we don't get as many cosmic rays as when there are fewer. And this is easy to measure. We measure it year by year. And cosmic rays ionize the atmosphere. And you probably remember the cloud chambers that were used in the early days of nuclear physics. So the Earth is sort of like a giant cloud chamber that's being ionized by cosmic rays, and the cosmic rays are modulated by the sun. And so to sort of end this long chain of reasoning, if you got a lot of clouds, it's cooler under a cloud. So the Earth is cooler on average when you have a lot of clouds, and a lot of clouds means fewer sunspots. So that's the basic idea of
what we've actually got here, though, is an incredibly complex system with multivariate degrees of freedom of all, many different kinds.
There are many factors. That's right. Yeah.
And yet, what people have done is they've focused in on just one possible factor, the CO2, and taken that as the king of all factors. And so that's the one thing which the climate change people are entirely focused on. Is that possibly because, and this is my next question, is the level of CO2 rising, and is it rising at the same kind of rate as the temperature of the Earth is rising? And is this why there is a strong focus on CO2?
Well, yes, to both questions. CO2 rates is rising in the atmosphere, and most people, I'm one of them, think it's due to human, combustion of fossil fuels. There are some people who object, but anyway, it doesn't matter too much to me. I think more CO2 is good for the Earth. And so CO2 is rising, and so is the temperature. But the price of postage stamps is rising too. And, so there's this famous fallacy that correlation is causation, but it's not true. Correlation and causation are not the same thing. And so,
are you saying that the rise of CO2 and the rise of temperature are unrelated or not?
I think it's mostly unrelated. That's correct. Yeah.
Okay.
Yeah, there are many things rising at the same time as the temperature. I mean, is it really the price of postage that's causing the Earth to warm? Right?
I think we can put that one to one side. I would hope so. But is CO2 rising as a consequence of man-made efforts, or are there other factors involved in this?
Well, this is an area of dispute. I think it's mostly due to man-made emissions because we're emitting twice as much CO2 from burning fossil fuels as is showing up in the atmosphere. So if you think it's due to man, your problem is where is the other half going? So half of what we emit doesn't show up in the atmosphere. So presumably that's gone into the oceans, maybe a little bit into sequestration on land from better plant growth. Plants are growing a lot better than they did 100 years ago, partly because of more CO2. So, I'm willing to listen to counter arguments, but I think it's mostly due to human emissions.
What's
it's good. I'm really pleased that it's going up.
I was going to say, what is the optimum level of CO2? At the moment, we're about 400 million.
Yeah, maybe 410, 420 of that order.
But I mean, and climate alarmists are suggesting that that's way too high, and it should be much lower than that. We need to avoid a tipping point, as they talk it.
Yeah.
But what do you think is the optimal level, and why?
Well, I think the best way to answer that is to look at geological history back in deep time. And, the Earth is a very old place, and our modern world really began in the Cambrian when we began to see lots of fossils. So there's a good fossil record. And at the Cambrian, CO2 levels were 10 times what they are now, maybe 20 times. It's proxy data, so there's a little uncertainty.
But there were no humans at that time, were there?
There were no humans that I know. not in the Cambrian.
The point is,
lots of trilobites, yeah.
You might say that the CO2 was 10 times higher, but would that have had an impact upon us? Is that one of the reasons why there weren't any humans at that time? Is it too high for human beings, in other words, is what I'm saying?
No. I mean, look, humans, we need CO2. Your breath is 4% CO2 when you exhale. And if you count it up, over a day, you exhale about 2 pounds of CO2. Every human exhales 2 pounds of CO2 a day. So there are 8 billion humans. Multiply that by 365 days, and 2 pounds a day. It's a lot of CO2. And so, one of the things that bothers me about demonization of CO2 is one of the main emitters is us. And if you listen to the crazies, they say, yes, you really are the problem. We have to get the population of the Earth down to under a billion people. And well, I look around, there are 8 billion of us, which 7 out of 8 has to commit suicide, right? It's a very, very dangerous philosophy, and it's not true.
There's a corollary to that, isn't there? Because I don't know if it's the same in America, but over here in the UK, there's a strong impetus to try to stop people from eating meat.
Yeah.
Because if you eat meat, you're supporting cows, and cows produce, I suppose, CO2 and at one end and methane at the other end, and both of which are...
Well, look, be fair to the cow. The reason the cow emits methane through its mouth, it just, if you've ever been in a bar and they're always belching, to chew the gut, burp, chew the gut, burp. The burp is half methane. And the reason the methane is there is the cow and other ruminants, sheep, goats, deer, have this extra stomach where they are able to digest cellulose. You and I can't digest cellulose. It's a compound of sugar, so you would think there was a lot of food energy, but our enzymes cannot break it apart. But the cow and the goat have these bacteria in the stomach that break it apart, but they're poisoned by oxygen. So they break it apart in a funny way, in which one of the byproducts is methane. So the cow's stomach keeps getting bloated with methane. That's why it has to continually burp out methane. But they've been doing that, since the world began. I don't know how
Yeah.
old.
But there are those who claim we should stop eating meat entirely. I've never quite understood the argument for that, but maybe it's
it's a cult. Look, I mean, you can't understand cults on the basis of reason, and we're dealing with a cult.
okay. Fair enough. Let me move on to my next set of assumptions here, which underpin the climate alarmism. So we've got the fact that the Earth is warming. We've got the fact that CO2 may contribute to it. That was one of the assumptions, and that it's increasing, and that mankind is actually causing the increase. But it may not be as dangerous as we think it is. But here's a question, particularly for a bureaucrat, as you called yourself at one time, and that is, should or could public policy actually stop the increase of CO2 if we felt we wanted to do so? I mean, people are wanting to go down that route, zero carbon. Is it actually possible to do that?
Sure, but it would be essentially suicide. So,
yes,
for example, you could have mass nuclear war and kill all the people, and CO2 would stop increasing. And the policies that are being urged on people, that are short of nuclear Armageddon, don't actually differ in the final result. They will also kill lots of people. Billions of people will starve to death, because you cannot support the world with the number of people we have today without fossil fuels. Maybe someday in the far future, people will be successful with controlled fission or fusion. Fission already works pretty well, and fusion may work someday. Don't hold your breath, but it may. And anyway, that's a problem for our great-great-grandchildren, because there's plenty of fossil fuels around for many generations of people now. There's a century or more in the ground.
But there's huge reluctance to use it by certain groups of people. And if you don't have free or cheap energy, it's only cheap energy which has taken people out of poverty right across.
That's right.
And
well,
if
that experiment was done in Sri Lanka a couple of years ago, and you probably remember what happened as a result of pressure from Western elites, and Western billionaires, airheads. They banned the use of chemical fertilizer, worried about cows and methane, and they greatly restricted fossil fuel imports. The result was massive crop failures. Every crop failed. Rice failed. Tea failed. I didn't know tea needed so much fertilizer, but it does.
Yeah.
And so people were starving, going bankrupt. And so last spring, the government fell, and there were, furious crowds, milling around the presidential palace. And had the president not managed to escape to a ship in the harbor, they would have hung him, and he's not ever going to come back to Ceylon anytime soon, because it did so much damage. But there's a case of what will happen. And that was really only mild. They only began, the recipe that was handed down to them by the environmental extremists. If you do it all, it really is suicide. People will simply die,
What worries me on that front is that Europe is going down the same route. I think they've got directives now which want to cut the amount of nitrogen-based fertilizers by 40 or 50%. I can't remember that. In my own country, in the UK, where we're directing farmers to use less and less fertilizers on the fields and that kind of thing. And it does seem to me to be something that's not without its consequences.
Well, the consequences will be horrendous, because, especially grains, wheat, oats, barley, corn, American corn, I'm talking about maize.
Yeah.
Need lots of nitrogen fertilizer, and the yields are up by factors of 3 or 4 or 5 compared to what they were 50 years ago, because of the use of nitrogen fertilizer. And so the only way you can support the current population of the world is to continue to use nitrogen fertilizer. Now, farmers, I have enormous respect for farmers. Many of them are brighter than most of my physics colleagues, you know, and they have to deal with a much more complex business than physics. You know, you have to guess what the weather's going to be, not only next year, but next week or tomorrow, and what to plant, you know, when to cultivate, when to harvest, and how much fertilizer to put in. And farmers are not stupid. They don't pay for more fertilizer than they need. So they have gradually learned to use less fertilizer, but it should be up to the farmer to put on the optimum amount of fertilizer that optimizes the yield from his farm. It shouldn't be some bureaucrat in Brussels or Washington or London, you know, making that decision. It's a very, very interesting topic, and you know, bureaucrats are always making the same mistake. You remember that one of the first things the Bolsheviks did in the Soviet Union was to collectivize the farms.
Yeah,
and
the kulaks were going off the farms, weren't they?
Yeah, that, and what's going on in Holland and today is very similar to the collectivization. You know, they're basically driving farmers from their fields. And
they want to close down, I think, a third of all the farms in the Netherlands, which sounds to me like again a recipe for making a lot of people hungry.
Well, that's correct. And, you know, what happened in the Soviet Union was the farmers didn't want to leave their fields. You know, they knew how to farm a lot better than some, you know, Bolshevik, you know, theorist in St. Petersburg or Moscow. So since they resisted, they were either executed or exiled, or they starved to death. So there were millions of people who starved to death during the collectivization. That, in fact, is one of the reasons for the Ukrainian war today, is the folk memories of what the Ukrainians call Holodomor, you know, the murder by hunger.
Yeah.
And so the same thing will happen again. We saw it happen in Sri Lanka. You know, fortunately, Sri Lanka is a little country and not too much damage to the world was done. But Holland is a major player, and Ireland is a major player. United States, Britain, or, you know, even Britain makes a lot of agricultural output every year. And a lot of that is due to nitrogen fertilizer.
What astonishes me is that the people who are making these decisions, either they don't understand the consequences of what they're doing, or they say to hell with the consequences, just we need to do it anyway. It doesn't make any rational sense to close down farming capability, growing capability in a world which needs food.
Well, you know, there are many human vices, but one of them is, one of the worst is the lust for power. And a lot of these people, you know, are hooked on power, you know, and in fact, they don't care what the consequences are. It's just that I've said that, you know, I've got the power, you better do it or else. And so we should be clear about that, that this is what is driving a lot of that. The other is, you know, greed, you know, that's somewhat easier to deal with. You know, everybody's a little bit greedy.
Yeah.
But, you know, the people who are selling windmills are making a lot of money, and solar panels are making a lot of money. Sustainable services, lots of money is being made there.
Yeah.
And a good fraction is going back to the politicians who mandate it. So there's this vicious cycle of political mandates, you know, which are very profitable for some section of society, and that section it gratefully pays back, you know, the part of the largesse that it reaped from these.
We're beginning to see some of the effects of these policies which are coming through in the UK. I'm not sure what it's like in the States, but in the UK, our policy is to go to zero carbon by 2050. And in pursuit of that, we've got a number of sub-goals. So, for example, the sale of all new petrol cars or diesel cars will stop by 2030. That's only 7 years away. And on top of that, there's going to be a stop on the sale of domestic gas boilers, despite various energy sources. We've put a stop to fracking as well, even though we have a lot of gas in the ground, that kind of way. But the consequences of all this are, it seems to me, quite dire. I just wondered, do you have similar policies, and what's your thought on those kinds of things?
Well, yes, I mean, the current administration, the Biden administration, is in sync with what's happening in the United Kingdom. And just as in the United Kingdom, a number of the conservative political forces, the Republicans for the most part, think that they want to be even greener than the Democrats. And so it's a recipe for economic ruin and more than economic ruin. And I believe that as long as we remain democracies, United Kingdom remains a democracy and America remains a democracy, that eventually the people will rise up and reverse the policies. Now, you know, that didn't happen in the Soviet Union. You know, they claimed it was a democracy, but it wasn't. You know, it was a totalitarian state. And you can see that impulse here too. There are plenty of Greens who make no secret of admiring China, where you can have a top-down decision, you know, and that's what's needed. That this is such a dire situation. You know, the earth is about to dip into, you know, destruction. That, you know, forget about democracy. We, the elect, you know, did you hear John Kerry at Davos talking about we, the elect? It's almost like from an outer planet, he said, you know, we're going to save the planet, you know, whether it wants to be saved or not, or whether it needs to be saved. So there's a crazy people, you know, and the religious fanatics, some of them are simply, you know, opportunists. There are a lot of those, you know, and some of them are useful idiots.
Yes, I did hear about John Kerry, and there are others too who are making similar kind of statements. Klaus Schwab, the head of the WE, whatever it is now, F, they also make similar kind of statements that they're trying to control the world in a certain way. I'm not so as hopeful maybe as you are about the prevailing powers of democracy. I would have been a couple of years ago, but since the lockdown situation, where we've been able to close down democratic accountability, close down society, close down everything, can keep everyone in their homes. I don't know if that's happened in the States, but it certainly happened over here. So it was illegal even just to go out and sit down on a park bench in a public park with 100 yards from anyone else. And it was quite a worrying time. But what comes out of that is that people seem to be malleable enough to be able to just accept draconian rules if the need is great enough. And one can easily see, possibly in the future, climate lockdowns to save the planet.
Well, yeah, people seriously talk about doing that. People would like to do that. I'm not enough of a sociologist to know whether the COVID example will be good or bad. I think maybe it will be good. A number of people think it will be good because so many people, at least in America, recognize it was complete nonsense. Yeah. And the government, people that you should trust, lied, you know, through their teeth. They knew they were lying.
Yeah.
And so you can demonstrate that, and you don't have to wait 40 or 50 years like you have to wait for climate to see whether these dire predictions come true. You can see it immediately. So it's possible that it may go the other way, that it will help us. I hope that's the way it goes.
Yeah. But the other strange thing which surprises me too is that there are two ways of tackling the climate change, if you want to call it that, a climate emergency or climate catastrophe, as some other people call it. I mean, you can fight it and try to eliminate all carbon to go down to zero carbon and try to suppress all of that with the dire consequences which you've spoken about. But what often is not spoken about is why not simply adapt to the changing circumstances? if there are flooded areas, why not build up those or move those people away? Why mitigation rather than adaptation? Does adaptation hold a particular approach that you would support, or what?
Well, look, when you talk about flooded areas, sea levels are rising. They've been rising since about 1830 or so, at the end of the Little Ice Age, when the oceans began to warm and expand. Some melting glaciers contributed to that. But the rates of rise are not accelerating. They're 2 or 3 millimeters a year. It depends on where you are on the coast, because the land is also moving up and down. But, you know, the Dutch have dealt with that for hundreds of years. And, you know, it's not so hard to plan a 2 millimeter a year rise of sea level, for 50 years in the future. That's not very much rise. So there's really nothing, there's no challenge to handling this. And we've done many, many stupid things in my country, in America. You know, we permit people to build flimsy houses right on the coast where there's a hurricane every 3 or 4 years, and they blow away, and then they say it's climate change, I'm entitled to compensation. Well, you know, as they say, you can't fix stupidity, but and so anything that happens, you know, that's negative, it gets blamed on climate change, when it usually has nothing whatsoever to do with climate change. And but adaptation, yes, adaptation is easy, it's effective, very, very cost effective, and we should be doing it.
We should. Okay. I've come really to the end of our set of questions. I've got one more question, which I think, if you'll bear with me, it's a more difficult question, I suppose. You've mentioned that we're sort of in the grip of a cult, but it's certainly the case that the prevailing narrative right across the entire world, it seems to me, except maybe in China, I'm not sure what they really think over there, but in the West, the prevailing narrative is that we have a climate emergency, maybe even a climate catastrophe. And pretty well everyone believes it, not just kind of cult kind of figures. You've got the IPC, though you may think that they're not much of a scientific organization. But I'm told that 101 Nobel laureates sign up to this, and even the Dalai Lama say we're facing a climate catastrophe. How is it that so many, let's call them clever, deep-thinking, sensible people have got this so wrong and so widely across the earth?
Well, you know, throughout history, the worst crimes against humanity have really been started by elites. You know, they eventually get some help, but for example, in our country, in the Salem witch trials, 1690s in Massachusetts, more than half the judges had degrees from Harvard. So the judges were not knuckle-dragging Neanderthals. They were the best and the brightest of that day. And the common people in Salem, in many cases, were not too happy with all of these trials. And on 1 or 2 occasions, the hangman himself almost got hanged because the surrounding crowd was so angry that they were hanging, you know, their pastor, who was a good man, you know, and accusing him of being a witch. That was George Burroughs. And we had a sort of similar movement in your country and mine in the late 1800s, early 1900s, the eugenics movement. Everybody signed up to it, you know, all the presidents of universities in America, you know, Alexander Graham Bell, you know, there were eugenics clubs of concerned women in every little town. They'd have tea every Thursday and wring their hands about the ruination of the good old Anglo-Saxon race, you know, by all of these low IQ Chinamen and, you know, Eastern European Jews and Italians. It was just complete nonsense. It was nonsense from beginning to end, but it was 100% accepted by the elite. I'm less sure about the common man. Again, the average American, I think, was not in on this, but for sure the media, the universities were. So this is not unusual, you know, and in every case it's been wrong and it will be wrong in this case too.
The difference between those kind of times, it seems to be, particularly Salem and the 1690s, the times of Jonathan Edwards and Princeton just starting off, all that kind of stuff, those were not primarily scientific times, not scientific in the sense that we are today. Today, I would expect people to make decisions based upon the scientific method. You make that case in your paper that the scientific method is the key thing which we should be making our decisions on. And yet we seem to have become a post-scientific method age. We seem to be making decisions on a moral basis. And if I don't like what you're doing, if you're a climate denier, then you're a bad person. There's no argument against it. You're just a bad person. It's a moral judgment, and people are dismissed on moral terms rather than on evidential terms or rational terms. How come we've moved from science into this new moral vacuum which seems to have created? There's any comments on that?
Well, I don't think it's really changed. We just talked about eugenics, and there were scientific journals on eugenics, and you could put in an article to show how low the IQ of Chinamen and, and Eastern European Jews were, and they get peer reviewed, and it was published, and it all looked very scientific. It was nonsense, so it was corrupt. And so this happens all the time. And so I don't think there's anything new here. Powerful people get onto an ego trip, and it gets amplified if there's some money involved, and there's a lot of money involved in the climate issue. And so it sort of develops a momentum of its own, and it eventually comes to an end when enough people recognize that we just can't do this, and
is there a way out, or we just have to let it burn itself out? Is there a way out that we can encourage?
Well, I think the only sure way to solve it is for some unfortunate country, or maybe big state, California, Germany, to do everything that the fanatics demand, and let the world witness, the results. And that's what really ended eugenics. It was not because people came to their senses. It was because it was taken over with a vengeance by the Nazis.
Yeah. And
so everything that they did, it was already proposed in England and America. They're sort of being Germans, they did it very thoroughly. But the results were so horrific that we don't talk about that anymore. It's not good taste to talk about eugenics or even IQ. It's maybe gone a little too far, but nevertheless, that's dead for now, for a long time. So these things can get cured by being pushed to the extreme.
Well, let's hope it doesn't get too extreme before we get to the end. But William Happer, thank you ever so much for a fascinating and very interesting conversation today. Thank you.
Thank you very much, Professor.